To recap. Thank you. All right, so NFT obviously non-fungible. Key thing is they are indivisible, unlike obviously other fungible tokens. Can represent a wide variety, diversity of tangible as well as intangible items, and very importantly, each and every NFT is distinguishable, is unique in some way from every other NFT instance. At the core, as we are aware, it is an asset that exists on a blockchain or a ledger. The ledger allows us, and in fact, everyone, to verify the authenticity, the provenance, the lineage, and more. From a consumer perspective, what makes an NFT interesting, and I suppose you could say potentially valuable, is that it's one of a kind and acts as a collector's item. And of course, the value in the eye of the beholder, the collector or the consumer, is the scarcity, or you could say the perceived scarcity. I want to just add a comment here based on my own experience. The way I think of NFTs and the commercial implications and the impact of NFT, this reminds me very much of the early days of the e-commerce era. I would say circa 97, 98, when we could see what was happening or what was going to happen. However, it was still so very early in the game. It's the same way I think of NFTs today. I think we can all foresee what is likely to happen. However, at this point, anybody who is in this particular sector building NFTs, NFT apps, stores, etc., I think is very much in the same position in terms of the market opportunity. There are two things that Harry and I wanted to share with you very quickly in terms of links. The first one is the NEP11 standard, which is what helps us to define an NFT on the N3 chain. If you haven't had a chance to look at this yet, I strongly recommend you do, not necessarily in this call, but certainly after the call. It will give you a very solid grounding in terms of the schema definition, the data, as well as the metadata. The second one, I would also urge you to take a look at, if you haven't yet, is the NEP17, which replaces the NEP5, as you guys are very much aware. It's also very useful to have a good understanding of the NEP17 schema and standard, as it will be of use to you in building commercial, real-world applications using the NEP11 standard, again on N3. So what we have done over the last, I would say, few days is to build a sample application, and I'll give it to Harry. He will take you through his design of the app. But again, two links I think you guys should be aware of. First is the link to the sample code. The repo will go public very shortly, sometime in the next 30 minutes. Also, as we will be using the blockchain toolkit to demo and walk through the code for you, I would also recommend you bookmark the second link here, which will lead you directly to the Neo blockchain toolkit, and which, if I may say so, I believe is the premier blockchain dev toolkit in the industry. Very briefly, there are three high-level scenarios in terms of the sample that we will show you very shortly. Harry, may I give this to you? Do you want to just quickly walk through the scenarios? Or if, let me just give you a quick summary and then I'll give it to Harry then. The first one that we have built is the Neo contributor token. The idea is to create an NFT of the various individuals who contribute to the Neo ecosystem. We figured it was a fun idea and maybe a fun way as well to showcase the possibilities and the potential. However, using individuals and people that you might already be very familiar with. Secondly, what we have done is, in terms of building NFTs, the commercial implications are very much, and very typically, I would say, in launching a store or a shop for the NFTs you build. So we've also done the scaffolding, the fundamentals in terms of a shop and the bare essentials of a contract. And lastly, also what we have is a fairly simple client application. And once again, the intent is to show what is possible, is to give you enough of a scaffolding to get you started. And of course, we expect and we certainly anticipate that you will build on this foundation and take it to obviously, heights that only you have in terms of your vision and the dream for your own project. So I think with that, let's shift to the toolkit. Let me stop sharing. And Harry, if you can hear me, I'll give this to you.
Yeah, I can hear you. Sorry, I was muted and I just needed Dennis to unmute me, but he has now done that, right? You can hear me, John?
Yes, I can hear you, Harry. Thank you. Over to you.
Cool. Let me just share my screen now. Okay, let me just, toolbars in the way. Okay, so the first thing I want to point out here real quick is the demo I'm about to show you today and the code that's in the repository. We've pulled a lot of the code. It turns out building NEP11 tokens, building NFTs on top of Neo is really, really easy, which makes for a really poor demo on my part. So as you can see here, this is the official Neo docs, and you'll notice that NEP11, which is as John mentioned, NEP11 is the standard for non-fungible tokens. This is, the docs are wrong here. They've got them backwards. NEP11 is for non-fungible tokens. NEP17 is for fungible tokens. Neo and Gas on the Neo N3 blockchain are both implemented as NEP17 tokens, plus people can build their own NEP17 tokens. There's actually a sample NEP17 token that NGD Enterprise has built several months ago. It may not be up to date to the latest builds, but it is definitely, most of the code is going to be the same. So if you're going to use this, it's actually really almost mind-numbingly easy. All you really need to be able to do is write the code that's, generates your, figures out the business logic behind how you generate your NFTs. Almost everything else is already there for you. As I mentioned, I pulled all the code into one file to make it easier for people to see. This is actually the code. This is the smart contract framework. When you build a smart contract in Neo, you have to you take a dependency on the Neo smart contract framework assembly. And in that this is the code from that library. And you can see here that if you look through it, all of the various standard operations, owner of, property, these are the things I can do. I can say, hey, who owns this token? What are the properties of this token? What tokens are available? What tokens does this person own? I want to transfer a token. All of this stuff is already built for you, plus a bunch of helper logic. Like here's a logic that you can use to generate a new token ID. If you have some existing method, you don't have to use this, but here's a library, the API that will give you some ability to generate token identifiers. Of course, the big one is going to be mint. I want to create a new one. Burn, which may or may not be necessary in your scenario. It depends on whether or not burning tokens is something that you support. And then this is just some other additional code. So basically, all you really need to do when you build your own contract is to write some kind of public method that calls this mint method, and everything else is taken care of for you. That doesn't help you understand all this code. So I've pulled all this code into this sample. This is what we call the Neo contributor token. So we're creating tokens out of the Neo contributors. And if you go to neo.org, I should have had this up earlier. There's a list of, here's a bunch of the contributors. Here are the core developers. I, of course, am smart enough to highlight my bosses. So Hongfei, Eric, and John, they're going to be our tokens that we use today. In this code base, we have two contracts, a token contract and a really, really dinky store for selling NFTs. part of the point that I wanted to do with this demo this morning was to be able to demonstrate not only how to write a token, but also how to work with tokens, right? How do I move tokens around? How do I accept tokens? How do I sell tokens? That kind of stuff. This is obviously dinky demo code, and I don't do UI stuff, so it's all command line or running in the debugger. And then we also have a very simple little client. If I start the blockchain, so here, as you can see, I am using Neo, the Neo blockchain toolkit. So I can just start this. I have to build it first as a first thing. The other thing you're guys are going to get today is a little bit of a sense of how my personal development workflow works. So hopefully that'll help you. Everybody has their own. Mine is based off of years of working on the command line inside of Microsoft. So it tends to be very command line heavy. I realize that a lot of developers tend to be a little bit more IDE focused. This is the way that I tend to work. So in here, there's a couple of things I want to quickly point out that are more general. First off, because this question came up on Discord the other day, I have a set of tools, the Neo Express, which is the personal developer blockchain as part of the blockchain toolkit, and NCCS, which is the C# compiler for Neo. I have both of those installed on what are called local tools. These are really easy to install. You can just install them from the internet. And what I've done here is I've got this file called .NET Tools, and there's instructions on how to do this. And I'm actually got to open up office hours on Tuesday morning at the same time. So that'll be a time where we can do all questions and answers. Today will be just presentation. Plus, I'm available on Discord, Twitter. You can find me. This allows me to install these tools specific to this directory, which is really important for me because I tend to have different versions of these things installed all the time for test purposes. So it's important for me not to use the global tools. Most of our docs are described around global tools. So in this, you'll see a lot of places where I'll say something like .NET Neo XP, and oh look, there's the help file for Neo XP for Neo Express. Most of you will probably be running these as global tools, so you'll just type Neo XP as an example. So in this, I've also got a series of tasks set up, and one of them is marked as Reset Neo Express. And so I want to just demonstrate right now, there are no, right before the meeting, I get cleaned. So I deleted all build files and all that. So I'm now going to build both contracts and the client, and I'm going to configure the Neo Express for running tests and doing the demos. And you'll see here that it actually is going to run extremely fast. One of the things that we have in Neo Express is the ability to, part of our philosophy when we were building Neo Express was that we wanted to make it very easy for developers to get things configured exactly the way they want, right? Sure, you can download a developer blockchain and it's already done. So I haven't even finished telling you about it and it's already finished building. I wanted to be able to configure it exactly the way that I want. You know, it's very common to be able to download a blockchain that's pre-configured and it's got an Alice and a Bob, and well, that's great, but what if you need different things? What if you need things that are not there? And so we wanted to make it really easy to configure it exactly the way you want. So when you run, when I do this build, you'll see that there's these steps here at the bottom where it's doing a bunch of these types of transactions. There's a bug. Some of these are marked as deployment, which are not. Code works. It's just the way it gets echoed to the console is wrong. So this is the set of steps that got executed when I rebuilt the contract. I transferred a bunch of the Genesis gas and Neo around to users. Owen is the owner of the NFT. Steve is the owner of the store. Alice and Bob are two customers, or two users. I deployed the two contracts, and then I created a checkpoint. Checkpoints are another key feature of Neo Express. They allow you to save the state of the blockchain in one specific spot. And you can then go back to it and run tests against it, and it's in a consistent state. I'm then going to mint 3 tokens, Hongfei, Eric, and John. I create another checkpoint. Alice buys one, and then Alice lists one on the store, and I create checkpoints for each of those. So what's cool is we can actually just start right off the bat with taking a look at the client. The client, as I said, I'm going to remind you guys, I am not a UI developer. So this is all console-based application. So I'm going to start the blockchain in the background. You'll notice also real quick that the blockchain hasn't actually been run yet. I did all of these transfer, deployment, invokes, all this kind of stuff. I did that without the contract, without the blockchain actually running. NeoExpress, as one of its developer features, supports what we call offline mode. And in offline mode, if you do an operation like I want to transfer gas or I want to deploy a contract, it will just quickly construct a block and mint a block with your one transaction and save it, instead of having to wait 15 seconds or whatever you've set your block time to. And for things like getting your blockchain configured, it's really great. However, that's not the way that anybody would normally communicate. That's only for developers. It's not the way that an application would actually communicate with the blockchain. So for being able to run the client, we actually have to run it in the background. So I'm going to just start the blockchain here, and you'll see that it's going to come up here. You'll notice, by the way, that it starts at height 14, because each of these transfers, each of these contract deploys and contract invokes created a new block. So it just automatically did that stuff for me. Now I'm going to open up a terminal, because again, everything I do tends to be on the terminal, and I'm going to change to the client directory, and I'm going to say .NET run, because I haven't actually built this for external use. I haven't packaged it up as an exe, and I'm going to say .NET run list. And now we're going to look at the code here for a second. I just want to show you how this stuff works first. And so there we can see that there are 3 tokens available. 2 of them are, sorry, 3 tokens that are there. 3 of them are, 2 of them are available, Eric and John, but Alice has already bought the Hongfei one. We'll look through this code here in a minute. I just wanted to give you guys a sense of what we're doing here. And then there's also an exe. I can say, okay, well, let's see if we can actually purchase one here. So I'm going to say buy, and I copied the token ID for Eric, and I'm going to say Bob. Now, one of the things here is that these Alice and Bob and Owen and Steve, these are all identities that are specified in the NeoExpress file. So these are wallets that are NeoExpress wallets. And so they don't use passwords and anything like that. This client application is specifically designed to read that file, which is obviously something you'd only do for development. One of the things that I want to focus on going forward is a little bit more support for generalized wallet. The COZ guys have just done a great job around a new wallet SDK that is based on Wallet Connect. And I want to look at getting NeoExpress connected into that, but they only released their stuff a couple of days ago, so I haven't had a chance to do that. But if I go back now and list a second time, we'll see that as soon as it runs, we can see now that the Eric token has been purchased as well. So all this code, this isn't particularly difficult code, but let's start actually looking through code. That's what you guys came here to see. I just wanted to give you a quick sense of what you could actually, like, that's the only UI parts of my sample today. So I just wanted to get those things shown so we could see this. So we're going to start with the token contract. And as you can see, it's not very much code. It's all of about 250 lines of code. And most of this is copied directly out of that the Neo token code I was showing you before. So normally what you would do is you would just inherit from Neo, NEP 11 token, and you'd have to give it a state, token state, something like this. And you'll see now that it's like, oh, look, you have all of these things you're overriding, these little yellow squiggles. So I just wanted to point out that the vast majority of the code that is in here is here for demonstration purposes. You wouldn't have to do it yourself. So this would be a much simpler contract. I'll publish a version of this that directly uses the NEP 11 base class. So in here, we've defined a class called token state. This is going to manage what we know about an individual token. An individual token has an owner. It has a name, a description, and an image. We saw that actually if we looked in the, when I had the console open, you can see here that I have Hongfei, his name, the stuff in parentheses is his description, and there's also a link to the image. So if I click on that, it should come up. Yep, it has a link. I've just pulled down those images directly from, I'm just linking to those images that are on that web page. So those are the pieces of information we need to store about every individual token. You'll notice, by the way, the token identifier is not one of those, because we're going to store this in a storage map. So the token identifier will be the key, and this will be the value. The next thing we have here is the transfer event. This is part of the NEP 11 standard. Whenever you transfer a token from one owner to the next, you have to fire off a notification. And in C# we map notifications to events. So this defines, who owned it, who's owning it now. The amount will be 1. John actually mentioned earlier that NFTs tend to be non-divisible, but it is possible to build NFTs that are divisible. For example, you can own part of a piece of property. That property is it could be modeled as an NFT, and a portion of it could be owned. You can't buy part of Hong Fei as a trading card. So you can only, here we're going to be working exclusively with full tokens, but you can actually, the NEP 11 standard does support divisible tokens. And then finally, the token identifier. What is the unique identifier for this token? And we'll be generating that in a little bit. So we define the delegate defines the shape of the event, the notification, and then the actual event is the thing that you call in your code. We then have a bunch of prefixes. We use these for storage keys. We store the total supply and balance like how many tokens have been created, how many tokens does this specific user own, where's the information about this specific token. Oh, I'm sorry, I take that back. That's this token one. Token ID is an internal increment that's used to generate token IDs. Account token is an index that allows me to quickly retrieve what are the tokens that are owned by a specific person. And finally, who is the contract owner? All of this is in the standard base class. This is the only part that I added. One of the things that the code doesn't, that the base class doesn't have is how do you control how you upgrade your contract, who owns your contract, that kind of stuff. That's pretty standard. That's not specific to NFTs, but that's something we try to put in every single one of our contracts so that you guys see the best practices. This is the sort of the simplest deploy update scenario there is, but we want to make sure that everybody does that. If you deploy a contract in Neo and you don't provide an update, then you can never update it. So it's important to make sure you have that from the beginning. So then there's some standard methods. What's the symbol for this? Mine's just called Neo contributor. How many is it divisible? It's not divisible, so it returns 0. What's the total supply? I'm not going to go through this code because this is all pretty standard stuff, but this is basically just retrieving, that stored value as an integer. Balance retrieves the stored integer for the individual user. Owner of is where we start to get more interesting. So here we're going to go through that index. That's the prefix token. Oh, I take it back. Yeah, this is going to go and retrieve. You know what? Let's get through this stuff. This is the exciting stuff here. Let's start with mint. So mint this is the first method that doesn't actually exist in the base class. So if you were building this from scratch and you were using the NEP 11 base class, you'd start with this. So in my scenario, a token has 3 pieces of information: a name, a description, and an image, and it can only be minted by the owner. So the first thing I do is I validate the contract owner. And so this is a common operation that I do in a couple of different places. So I've broken this off into a separate function. So we'll scroll down and take a quick look at that. It's at the bottom. So what I'm going to do here is I'm going to go use that contract owner prefix. I'm going to retrieve the owner's address, and I'm going to check that against the sender of the transaction and to make sure that they're the sender, that they signed the contract. So you have to be the sender of the transaction, and you have to have signed the contract. You have to have signed the transaction. So this way we're sure that only the owner can validate, can mint new tokens. It turns out that only the owner can update. So here's that update method I was telling you about. Only the owner can update the contract. But again, I don't want to get into too much about that right now. So now the next thing I do is I'm going to generate a token ID. I wanted to do a slightly different thing, so I'm not using exactly the same code from the new token ID, but you could just call new token ID in this context here. And then what this is doing is it's reading that integer out of the storage. So this is just every time you mint a new token, it increments by 1. Now you can, of course, tokens all have, we only, in this scenario, we're not burning tokens. So it is possible to mint and burn and mint and burn. This only will track when you mint a new token. So that way nobody will ever have the same more than one ID. So we take that, we generate a string, and then we hash the string. So that way we get this, we saw earlier, it was a big long hex number was the token ID. So then we create a new instance of the token state. We save all this information and we save it to the map, and then we update the balance and total supply. This is like what, 15 lines of code? This is the heart of the part of the token that you actually have to build. I'm not kidding. That's the reason why I have so much other code in this demo, is because I can't do an hour to talk about just this one function. That's how easy it is to build a NEP11 token, an NFT token on Neo. So what are some other things that I decided to add to this contract? Well, if you're selling a token, then that means somebody's going to buy it. And if somebody's going to buy it, that means they're going to give you Neo. So how do you buy it? Well, it turns out that the other thing is, how do you buy it, right? I take it back. There's minting it. How do you create it? And how do you buy it? So in Neo, there are standard operations for transferring NEP11 NFT and NEP17 fungible tokens. And so what this contract does is it implements on NEP17 payment. So what this is saying here is the way that you actually purchase an NFT is you send Neo to this contract. Seems like a reasonable way. You send money, we give you the token. So here, this is the standard. This is a standard method that can be implemented on any contract to say I receive I receive fungible tokens. So in this context, you get who's sending the money, how much money are they sending, and then some piece of other data, because this is going to be contract specific. So it just comes in as an object. So what I'm doing here is I'm checking to see, is the data null? Because in this context, you need to tell the caller needs to tell you what actual NFT are you buying, right? It doesn't do you any good to just say, here's 10 Neo, here's 10 Neo, I want the Hong Fei token. Here's 10 Neo, I want the Eric token, whatever. So what you do is you pass in that token identifier as that extra piece of data. So we do a cast to get that information out. We check a couple of things. First off, you have to send us Neo. So one of the things in this is that this method is used for all NEP17 payments. Neo is a NEP17, Gas is a NEP17. Third parties can implement their own NEP17s. They all use this method. So I need to check to make sure that I'm receiving the correct token type. Of course, if you wanted to accept other tokens for payment, you could, but in this scenario, I'm only accepting Neo. And then you have to send at least 10 Neo. Again, this is obviously, pretty hard coding a value for the NFTs. One of the points about NFTs is they tend to have very, different sets of values. And so you probably, from a business logic perspective, want to do something a little more interesting than it's 10 Neo. And then it goes off and says, great, I'm going to go pull the Neo out of the token map. I'm going to go pull the Neo token. I'm going to go pull the NFT out of the token map. I'm just going to go get the token map. I'm going to go retrieve the data. I'm going to check to make sure it's not null, because if there is no token for that token, if there's no token data for that token ID, you've given me an invalid token. So I throw an exception. It's important here to throw exceptions if you get something wrong, because you want to make sure you cancel the payment. Right? It would be very uncool to accept the payment without having any, without returning giving the actual token. So here, whenever there's a mistake, since this is a payment, I make sure to throw an exception to abort the transaction. So if the token data is null, if there is no token without identifier, I throw an exception. I then deserialize it. I check to see who the owner is. This is another sort of question around business logic. How do you track who the owner is? I've set it to 0. In having actually built this all the way through, I probably would have been better off by specifying the owner of the contract, the owner of the token being the contract on Mint rather than 0. But that's the model that I used. I might update that later, but I had to make sure we had a working end-to-end demo for this morning. So, and then I transfer that token. I'm going to call the transfer function, which again is implemented as part of the base class. I'm going to transfer that token to the new owner. So again, all you really need in order to build your NEP11 token is you need some way to mint tokens. That's this function. You need some way to accept payment. That's this function. You need general, contract management stuff. That's this update, this deploy and update method. And then the last thing that you need is the ability to actually retrieve the Neo. So I've added this additional method called withdraw. So withdraw basically says, I'm going to take any Neo that this contract owns and transfer it to this address. But again, I'm going to validate contract owner. Only the contract owner, only the NFT token, only the NFT contract owner can transfer the Neo. So that person, so we check to make sure it's the owner. We make sure that we have a valid to address. We don't want to transfer the Neo, into the ether. That's not I didn't mean to make that joke. And then I'm going to get the balance. How much Neo does the contract currently own? If the contract doesn't have any, we'll just return false. This is one of those cases where we don't actually need to throw an exception because we haven't actually made any changes to the state of the contract. That's different from NEP 17. In the NEP 17 payment, this is called from whichever NEP 17 token is being used, in this case, Neo. So NEP 17 payment, that payment has already been sent. So if you don't abort the transaction, then that payment will go through. So you need to make sure that you throw exceptions if there's something wrong with the payment, like it's not enough or the token doesn't exist or something like that. So now we've seen this basic code. Oh, I'm sorry. I was just saying, so here I can just return false because I haven't actually made any changes. And then finally, I do the Neo transfer from the contract. The runtime executing hash is the identifier of the contract to the address that was specified. It is possible for the contract owner to say, I want to transfer the Neo in this contract to this specific address. It doesn't have to be only to theirs. So let's actually see this run in the debugger. So I've configured, if you can see here, I've configured a lot of debug launch operations. And that's perhaps a little more than you would normally use. But again, I want to make this really easy for anybody to pick up this, this repo and sample and be able to use it. So we're going to start with seeing how the code works with Mint. So if we look at the Mint operation here, you can see here that this is all the goo that Visual Studio Code needs to know how to launch your contract. The important thing here is a couple of quick important things. One is, what data checkpoint do you want to use? If you recall, I actually created multiple checkpoints while I ran the configuration. I have one, contracts deployed. So that's contracts have been deployed, but no tokens have been minted. Tokens minted means I've minted the 3 sample tokens, token bought, token listed. So I can actually get the blockchain in exactly the state that I want so that I can run the debugger against it. So the checkpoint is important. And then the invocation says, what am I actually going to invoke? I'm going to invoke the mint operation. And then here are the arguments that I'm going to pass it. And then finally, who's the signer of the contract, right? And so in this case, this is Owen. As I mentioned, there's a Neo Express file here. This is just a JSON file that has all the information that Neo Express uses to drive its experience. And one of the things that it has wallets for Owen, Alice, Bob, and Steve. And as a quick reminder, hey, look, there's Steve's private key. We store this stuff in the clear. Don't use these wallets anywhere important. They're only for use on Neo Express. Please, please, please don't use these tokens anywhere else, these wallets anywhere else, because these private keys are not being stored in any kind of secure fashion on purpose. Because of course, it's a lot more convenient to be able to do all this stuff without having to worry about passwords. So let's go through and look at the Mint operation. So you can see here, we've just stepped right in. You get a normal debugging experience. For those of you who haven't had a chance to really play with the Neo blockchain toolkit, this is the debugging experience. It's like any other debugging experience. So we're just going to step through, and we can see here in our we've gotten the key, we've gotten the current key, because I've done this on top of the already minted. There's already been 3 tokens minted, so I'm going to generate the next ID will be 4. Of course, its ID is 3 because you start with 0. So 0, 1, and 2 were the first 3 that were minted. So this next one will be 4. And I generate the token string. And so here's that token ID. It's going to be this long binary hex number. By the way, one of the things that we need to do a better job documenting this, but you can sometimes say, like, gee, I'd really like to see this as some other type of value. So if I actually add this to the watch window, I can actually control a little bit about how this is displayed. I can show this as a byte string. I can show this as a byte array. This is really valuable if you have something that's like supposed to be a string. Here we know name is a string because C# tells us it's a string, but it is possible that you have a byte string that is actually a string under the hood. So you can actually say, oh, I want to treat this as a string. So that's documented up on the Neo debugger GitHub repo. We need to get some better docs on that, but I just want to point that out because that's something that comes up every once in a while is, gee, I'd really like to be able to see this information as something a little bit more user-friendly. As I said, this is going to be a little bit of a, here's how Harry builds contracts kind of talk. So then, here I've created the token state. So you can see here, here's a good example, right? So here, the token state comes across as an array. And so if I want to actually see this as a add to watch. So I can see that token state 0 is a byte string, but if I put str as a cast operator in front of it, oh, we found a bug. Okay, somebody want to file that? No, I'll do it. Yeah, I'll have to show that later then. Anyway, so back to the actual demo code. That's how you can tell this is live code, right? Because we're actually running into occasional small bugs in the system. This is not quite finished yet. Anyway, so here we're going to now, we've created the token state, and we're going to create the token map. We serialize that information out, save it, update the balance, update the total supply, and we do a post transfer. By the way, one of the things you'll notice here in the, if I can bring the terminal back up here, if we look in the debug console, you'll see here, this is remember, this was we just called the transfer function. And so this information about events, notify events, which is what C# events get modeled as, and log events all get echoed directly to the console. So you can actually see that in real time while you're debugging. And that's that. That's the whole contract. That's the whole mint operation. As I mentioned, it's not particularly complicated. And then we also have the mint operation, we only have support in the debugger like invoke files. I haven't actually built any UI for that. We do have this client application. The client application has, we saw earlier, it has a list operation. So I'm going to, this code is using express chain. Express chain is basically the C# class that represents the Neo Express file. So this way I can get access to all of the users, I can get information about the RPC endpoint that I'm going to hit, that kind of stuff. This is a little atypical, this part of the code with using express chain, but the rest of this stuff is all the way that you would typically execute operations. So here I'm going to, here's another piece. Actually, during development, the contract, every time you make a change to the code and redeploy the contract, it's going to change its identifying hash. So during development, it's very common for you not to know what the contract hash for your contract is until you deploy it. Obviously, with mainnet and testnet, you'll deploy that contract and you'll have a well-known endpoint, and you'll just have to hit that. So you won't have to do this like, hey, I need to go up and look up the contract hash at runtime. You'll be able to embed that in your code. So here, this is just some code to say, go get the RPC client, use the RPC endpoint that's in the Neo Express file, and then go ask the blockchain, hey, tell me what this list contracts async is a custom function that only Neo Express supports. And so you can ask it, it'll tell you what the list of the contracts are that are deployed in the blockchain. Anyway, so the rest of this code is actually pretty standard NEP 11 stuff. So I showed you earlier in the contract that there's a bunch of these standard functions, right? So balance, total supply, what are the total number of tokens that have been minted, balance of, what are the number of tokens owned by a specific user, who owns a specific token, what are the properties of a token. These are all standard operations that every NEP 11 contract has to support. And these are all, I copied and pasted. I did add a little bit to this properties, like the description and the image, but all the rest of this code, I just copied directly out of the NEP 11 base class code. But one of the important ones here I wanted to show was owner and tokens of. So these are both functions that return information about the minted tokens. So tokens will show you information about all of the tokens that have been minted. Tokens of will show you information about tokens. It'll return the token identifier for all of the tokens and for all of the tokens owned by a specific user. These are standard. You wouldn't normally implement them yourself. They would just be there automatically as part of the base class. So here, I'm going to actually list them. When we saw in the terminal before, when we saw this list of tokens here, if you'll recall, down here at the bottom, there's the name, there's the token ID, there's who owns it, et cetera, et cetera. So what we're doing here is we're going to iterate over the list of tokens, And then I'm going to go off and retrieve the properties of each token as I go. I'm going to retrieve the information. The properties comes back as a map. So I'm going to retrieve the information out of the map. You get its convert the, the owner is a uint 160 and the others are all strings. And then I'm going to write them to the console. So this kind of code here, obviously, most of your apps are probably not going to be console apps. If you've got some type of operations, like something like minting, for example, maybe you only build a command line app. But apps that you're going to have for normal users, for things like I would like to browse the NFT store, or I would like to manage my NFTs in my wallet. These are all things you're not going to build on a command line. You're going to want to have some kind of actual UI for them. But as I said earlier, I tend to be poor at building UI. Here's the buy command. So we saw buy also earlier. Again, we're going to get the RPC client. We're going to get the contract hash at runtime. You can see here we've got a lot of comments in these codes. So I'm going to add some more comments. But the part of the whole point of this is that it's a sample. We want you guys to be able to understand it really easily. So I'm going to retrieve the wallet information from the express chain for the user that was specified. We did this earlier. We said, we're going to show Bob buying an NFT, and then I'm going to just call transfer. This is a standard API in the RPC client. I can create a wallet API and just call it. And so I'm just going to pass it. You can see here's an example of how you call it. I'm going to transfer Neo. So I'm calling it the Neo contract, and key pair is used for signing it. Contract hash is who you're transferring it to. That's the 2. So I'm transferring it to the actual contract. I'm transferring 10 Neo. And then if you'll recall, in the mint, in that operation for NEP 17, here's the on NEP 17 payment, we receive the token ID that we're trying to buy in this data field. So if we look at the buy command, this is the calling side of that. We're going to call the transfer function. We're going to pass it who's the 2, contract hash, how much, 10 in this case, and then finally that final extra piece of data, in this case it's the token identifier. So that's basically the way that this all works, is that you're going to do a transfer. The final thing here is that you can also, I've added this little support for wait. So normally what will happen is you'll submit the transaction. This transfer function says, I'm going to submit this signed transaction to the blockchain. And then if you're familiar at all with how Neo works, it gets added to what's called the mempool, and the consensus algorithm will eventually pick it up and say, hey, let's put this transaction in the next block. And then the consensus algorithm runs and they decide, yes, this one's in there. And then it gets added to the blockchain. So there's a gap of time that can be, it can actually be, multiple, it could take multiple blocks before your transaction gets picked up, depending on what the replication rate of the blockchain is at that time. And it can be, and obviously, the block only the new block is only minted every 15 seconds. So even if you get minted even if you get added to the very first block after you submit your transaction, it could be up to 15 seconds before your transaction is live. Of course, with Neo, you get single block finality. So once your transaction is added, you're done, which is one of our big selling points. But if you pass -wait, you can actually use the wait transaction async operation to essentially pull the blockchain and block until such time that the actual transaction is complete. And then I'm going to go off and retrieve the application log so I can tell whether the transaction succeeded or failed and how much gas it took. If you'll recall, back in the batch file, I transferred a bunch of Neo and gas around because, of course, all these operations require gas in order to be able to execute, when you do these transfers, when you do the minting, when you do the withdrawal, et cetera, et cetera. So I'm only at 45 minutes, and I've already walked through all the stuff you need to know to build an NEP11 token, and all the stuff you need to do some basic stuff about how to actually communicate with your NEP11 token from some client code. And I knew that we weren't going to have enough. As I said, this is very straightforward code. So I also wanted to demonstrate how one would go about selling them. So I've built this very simple contract called the demo shop, and there's not even console UI for this. I can only walk through this in the debugger for you guys. We'll probably build some sample code on top of this, but I didn't have time to get that finished before today. So again, this is actually a completely custom contract. So there's this you'd have to write completely from scratch. So again, you'll notice though that it follows a similar kind of pattern here. So I have a bunch of state that I'm going to manage for every what's called a listing, right? So I'm going to list an NFT for sale. I'm going to then I'm going to fire events when I create or when I remove a listing. Listings can be removed either because they've been sold or because they've been canceled. This contract has both on NEP 11 and on NEP 17 payment. So if you are going to list your NFT for sale, you're going to do a NEP 11 payment. And if you're going to buy a listed token, you're going to call into NEP 17 payment. And then finally, there's also this cancel listing and create listing. Well, actually, create listing is called from on NEP 11. That's its public endpoint. So there's also cancel listing, which the owner of a token can say, yeah, I don't want to sell this anymore. And then finally, complete sale. These are just helper functions. I'll go through them in a minute. I can also get a list of all the listings. I can withdraw the contract owner. As you can imagine, if you're going to run a shop, you're going to want to run it at a profit. So the way this specific demo works is you have to pay at least 1 Neo more than the listing asking price if you want to purchase a token in this shop. And so that means that you'll gather up tokens and you can withdraw them at your leisure by calling the withdraw function. And then, of course, we have, again, best practice. We have a deploy function that captures the contract owner. We have an update method, and we have a validate contract owner method. I also have a little helper function here. You'll see here in a second, when you go to transfer Neo, it's actually, there's a built-in class for transferring Neo. Let me just find that real quick here, right? So Neo.transfer, it's nicely strongly typed. It's, you know, the debugger, the IntelliSense will help you. You can hover over it and you can see its signature, that kind of stuff. The NEP 11 transfer for some, you know, for some random contract, there's no helper function for it. So I built my own. And so this basically similar to Neo transfer, NEP 11 transfer. The only thing that's different here is you'll notice the first parameter is the script hash. With Neo transfer, it already knows the script hash. It's Neo. With this NEP 11 helper function I built, you need to tell it the script hash. And this is literally a one line of code. It's basically just wrapping contract call. So it takes this line here, which is loosely typed, and turns it into this line here, which is strongly typed. It's just a little easier to write code against. Anyway, so let's actually look through the code real quick. So the process starts with the owner of a contract, owner of an NFT transferring their NFT to this contract. So you'll see here that, again, this is a standard function that gets called, and we're going to do a bunch of checking. And again, because this is a payment function, we always throw exceptions if something fails, because we want that payment, that transfer to fail. We want it to roll back. So the owner of the token, if for some reason they don't, if for some reason the token sale is invalid for some reason, we don't want it. We want them to get their token back. So first we check to make sure that the address that is sending it to us is valid. So we check to make sure that it's invalid, it's valid, and it's not null. We check to make sure that it's the amount is 1. As I mentioned, Neo actually does support fractional NFTs, but this store does not support them. So you have to pass it the entire token. You have to actually tell it a token ID. If you don't give it an actual token ID, then it's not valid. Finally, price, we check the price, and the price can be anything, but it has to be a positive number. So you can't list a item for free, and you can't list an item for a negative amount. And then we jump to create listing, which is, I just separated that out to make it a little easier. We combine the token script hash and the token identifier. So the token script hash is, because of course you can actually have lots of different NFT scripts, right? So this is, you know, the Neo contributor NFT is one of potentially many. So these two combined uniquely identified the token ID. There's no guarantee that different tokens might use the same token ID mechanism, right? If you could imagine that they could just say, oh, I'm token number 1, I'm token number 2. That's probably not a best practice. That's certainly not the way that the NEP 11 base class works, but there's nothing that stops developers from doing it that way. So what we do is we take the token script hash, which will be unique, and the token ID, which may or may not be unique, and we combine them and we hash them to create what we call the listing ID. And then this code looks very similar to the code we saw in the mint function for the NEP 11 token. Once you start to get the hang of contract development, the vast majority of it is get a bunch of data and put it in the storage, or get a bunch of data out of storage and do something with it. Fairly straightforward. So here we're going to create a listing state. We're going to create a listing map. We're going to store the listing in the listing map by serializing it out. And we're going to fire an event that shows this, that we've actually created this listing. In order to complete a payment, so you create a sale by transferring the token with a price to this store contract. You buy a token that's listed for sale by transferring the right amount of Neo to this contract, and you specify in the data field. Here, the data field for the NEP 11 payment is, this is how much I want to sell it for. This data here is, this is the thing that I want to buy, because I already know what the amount is because it's listed right here. So I do a lot of that same kind of checking. I want to make sure, is that from address accurate? Is the calling hash, again, this store only works in Neo. A more complicated store would support other token types, but this is a sample. Obviously, payments have to be positive numbers, and you actually have to provide information about the listing. So if you don't provide any information about the listing, we throw. And then we call this other helper function called complete sale. It's just a little easier for me I like it to break this stuff out into separate functions so it's easier to understand. You don't actually have to, you see here that this complete sale is only called from that NEP 11. You could have just put all this code together. So we then retrieve the token, we retrieve the listing from the map. If the listing data is null, it means it's not a valid listing. So we return false. Now, you remember I said earlier that we want to throw if there's some kind of problem, but you'll notice here up in NEP 11, if complete sale returns false, we throw an exception. So we're handling the exception here and on NEP 17 payment, and these helper functions don't actually return exceptions or anything like that. They just return true or false. I also tend to like to runtime log. This runtime log will end up in the debugger. So as I'm working through this stuff in the debugger, this stuff shows up in the debugger. So I like to do a lot of these runtime log type operations, but that's a personal preference. When you're actually running on the blockchain, these log operations, unless you are building some custom plugin to listen for them, these will disappear. So these are great for local development, but they're not as potentially useful on the public chain. Unlike the notifications like this, the on listing removed, on listing created, those do get saved. Those are part of the application execution information. Anyway, so completing a sale, we go get the listing, make sure the listing is valid. We make sure that the price that you're paying is valid. So you have to pay at least 1 Neo more. So if I list something for 20 Neo, then you have to pay at least 21. And if that doesn't work, we mark it as insufficient. And then we do the 2 transfers. So we start by transferring the Neo to the original owner, but we only transfer them the price that they asked for. So even if the person decides that they're going to buy the token for 100 Neo and it was listed for 20, that anything above the 1 is a tip for the store owner, I guess. Again, this is you could imagine that for business logic purposes, you might be better off to say, hey, we're going to check that the price is exactly correct, and so that way we don't want you to accidentally send us more Neo than you should. You could imagine that would be useful for a store, but this is demo code. So I transfer the Neo to the original owner. I transfer the token to the new owner. That's the buyer that's coming in here as a parameter. I delete the listing, and I fire the on listing removed event. Now, one thing to remember about a contract is all of these operations, right? So there's, we're doing 3 different stateful operations. We're calling into the Neo contract to transfer Neo from that was transferred to this contract as part of this operation. We're going to transfer this to the original owner of the contract, of the token. We're going to transfer the NFT token, which we received previously, to the buyer, and we're going to delete the listing. But all of this stuff either all happens together or it all fails. It's inherently transactional. So you don't have to, if you were writing this code to work with like a SQL database or something like that, you'd have to do a bunch of like start a transaction, end a transaction, commit, rollback, blah, blah, blah. That just automatically happens on Neo. You don't have to think about that. You just do these operations. And then finally, we fire the event. And then, as I mentioned, there's a helper function. So here, this is really simple code. This basically just iterates over the listing. So we find all of the listings that are currently available. We stick them in a map, and that we then return to the user. And then the final thing here is to cancel a listing. The way that the way I tend to structure is I tend to put all my public operations at the top and all the helper functions below, which is why I'm having to scroll back and forth. As I mentioned, this is kind of a, how Harry builds stuff. And so here's the cancel listing. We have, we're going to just go retrieve the listing. We're going to make sure that the owner of the original owner of the listing has signed this contract, right? So I can't, like, if John buys the Hongfei token and lists it for sale, I can't go cancel that sale. Only John can cancel it. And then finally, we do that. So we call that same NEP11 transfer function, except now we transfer it back to the original owner. And we delete the listing, and we fire the on listing removed event. So we can actually see these run in the debugger. So if you can see here, you'll notice, by the way, that I have list 1 and list 2, list NFT1 and list NFT2, by listed 1 and by listed 2. The reason for that is that right now there's a feature that needs to be added to the debugger that we had in where you can actually debug through multiple contracts at the same time. And right now that's not working. So I need to fix that. So we're going to actually show the listing. This is going to show, I see we're almost out of time here. So I'm just going to finish this up and then I'm going to take questions, but I'm almost done here, I promise. So in listing 1, we're going to debug the token side of the listing. And in list 2, we're going to debug the shop side, right? So when you go to do a listing, you're calling into the token contract to do a transfer, and then you're going to invoke that into, that's going to then call into the store contract. So if we go here and we say, let's do the listing. So we can see here, we're just calling into the standard transfer function. And if we get through to the end, we walked through this kind of code earlier. This isn't that exciting. Let's step out here. But the thing that is interesting here is that if you call into post transfer, you'll notice that what it's going to do is it's going to fire the transfer event, and then it's going to look at the to function. It's going to see, is the to function a contract? If you are invoking a contract, if the receiver of a token, NEP11 or NEP17, is a contract, then you have to call the on payment function, the associated on payment function. And that's what this code is doing here. So this is just showing that once we've done all the transfer, it's going to call into that on NEP11 payment function. And eventually you'll be able to step directly into it, but you can't right now because I need to make some changes to the debugger. But I can do the second side of it by the other. Again, that launch configuration information this is identical to launch 2, except for the program. So this is how it knows how to find the debug information. So if I do listing 2, all the stuff we just saw has already happened, and now we're stepping into the NEP11 payment function. And we can see this is the stuff we just talked about. We checked and validate the sender, we checked the amount, we checked the token ID, we double check, we get the price. And so you can see here that the price is 20. That looks like a bug there. And then we create the listing. Oh, I know what the problem is here. That's a known bug. Okay, so the variables information is I'm waiting on a fix on this from the compiler team. So so we can't. The variables aren't very useful, but we can look at the rest of this listing information. We create the listing. We create the state. And by the way, as a quick reminder, I was telling you about this earlier. Any of the information, the event information, will show up here in the bug. There's the transfer notification, and as I step over the next line of code, there's the listing created notification. So we get that information directly. This data also shows up in the execution log for this transaction, but of course, it's easier to see it this way in the debugger. So that's pretty much the whole demo, and I'm a minute over. So I've shown you how easy it is to build a NEP11 NFT token on the Neo N3 blockchain. I've shown you some very simple code for how you can interact with a NEP11 token from the outside using RPC client. And I've demonstrated a relatively simple NFT store that shows you how to do NEP11 and NEP17 payments. So with that, I think John just messaged me privately that he flipped the the publicity. He made the repo public, so you guys can all get access to this code. And I'm happy to sit and take questions. Either Dennis, I don't know if you want to do that here or on the on Discord or whatever, but I imagine that I've been talking for an hour and usually there are questions after that. So I'm more than happy to take some time now to answer questions about this sample or about Neo development in general. I see there has been a lot of chat. Unfortunately, it's hard for me to chat while we're talking. So
no worries, Harry. I think there was a lot of back and forth, but I was able to answer a few. I think we'll go to Discord because we probably are at the hour. Just want to make the final comment, guys. We do have the N3 pet shop, and that's more of a full-fledged store sample app. So we would strongly recommend, if you have a chance, to take this current sample code as well as the pet shop to help you build a NFT store on top of N3. Just a quick reminder on that one.
Well, and the one thing that's really nice about the pet shop is it has like an actual like non-developer UI. So that's actually, there's, in addition to the Neo Pet Shop, there's also a Neo Pet Shop Electron repo that has the UI. I'll drop a link to that actually, I dropped a link to that on the Discord earlier this morning, so that's probably good enough.
So Dennis, I don't know if you can hear us, but back to you. I think we are just past the hour. Want to respect schedules and times, so perhaps we should take the chat and questions back to Discord, but we'll give it back to you, Dennis.
Yes, definitely. Thank you, Harry. Thank you, John. I'm sure it will be incredibly helpful to anyone looking to develop NFTs on Neo. Yes, we are over 1 hour, so let's continue our discussion on Discord if anyone has more questions. I see that chat discussion here was very productive today as well. So this workshop was recorded and will be uploaded to YouTube in the next 24 hours. We have 2 more workshops coming up. The schedule is on DevPost. So there is one on dApps. The topic will be building dApps with governance on Neo. Nice. And then the last one, we will have just Q&A, office hours. For 1 hour, you will be able to ask your questions.
That's next Tuesday, right, Dennis?
So that's on June 29th, 9 a.m. ET time.
Yeah, it's Tuesday. Yeah, I'll be there. I'll be there to answer questions on. I assume I'm not the only one, but I will be available. I'll be there for office hours on Tuesday.
Great. So this workshop and all previous ones were recorded and are on YouTube as well. Thank you, everyone, and see you later. And let's talk on Discord.
Thanks, guys.
Goodbye.